wasting our time, um, binary logistic regression is another type of regression, different from the linear and multiple regression that we used to do with the ordinary least square method. Now, these, in cases of the linear and multiple regression that we used to do, the dependent variable is always measured on a continuous scale of measurement. It's always measured on a continuous scale. But what happens whenever we want to predict a variable that is measured on a dichotomous scale, that is measured on a non-continuous scale, right? What happens? The multiple linear regression will not be able to handle it. Hence, we need a logistic regression. Now, there are many types of logistic regression. We have multinomial and we have logits. You know, but binary logistic regression is what we're going to be doing tonight, and it's the most, I think, so far so good as I know, is the most used, according to what I know, like, is what is most used, and it's very, very useful we have our dependent variable measured on scale. That is, the response variable is measured with a response. Okay, rich or poor, tall or short. Whenever our response variable is measured on two responses, okay, we usually consider having a binary logistic regression to predict such variables. Now, from my slide here, I said in situation whereby dependent variable y is dichotomous or binary in nature, the simple linear regression will be helpless. Hence, it calls for a logistic regression. Now, logistic regression is just to predict the relationship between predictors and a predicted variable, where the dependent variable is binary. Okay. So now, this is all I have in my slide about binary logistic regression. I'm sorry I didn't cook up the methodologies or the big notes that we may be wanting to see. I'm sure this is not our first time hearing about this binary logistic regression. And I said it earlier, I don't want to bother us with the methodology. I just want us to do something handful, something practical, straightforward. Now, the data set we are going to be using this evening was extracted from the Nigeria Demographics Survey data of 2018, right? And it was extracted, the variables extracted here are to predict the wealth index of our respondents. Okay? Either you are rich or poor. I'm going to explain my data set now before we go into the wealth index of our respondents. Now, if you are considering wealth index of a person, there are certain things that can be used to predict it, right? Like the region, either south-south, north-central, southwest, southeast, or whatsoever. The region that you come from might, have an impact on maybe on the level of your richness. It can, we can use it, right? That's why I included it in the variable. This is it. We have our region, okay, and the place of residence. Then the other sites in a city. In fact, hearing it, maybe I say I live in Ilorin, and some other person said he lives in London. You will immediately say the person living in London is richer than me, because we already know the location, place of residence can determine. So our place of residence is also here. urban and rural. And your educational level, I think you're used to predict educated or not. Now it is in 4 categories: primary, no education, primary education, secondary, and higher education. Now, okay. So also your ethnicity, either you are Hausa, Igbo, Yoruba, and others. Others here are all those minor tribes, Edo, Efik, Ibibi, all those minor tribes. So, and then your religion, whether you're a Muslim or a Christian, we may not include in our model, but then literates and non-literate, right? It should. I think I included it as well. Then maybe you own a mobile telephone or you don't have a mobile telephone. I think you can use it to check as well. All right. Then our main variable that I want to predict is rich and non-rich. Now, the binary logistic regression can also be used. For example, I have a data set on anemia level where I have the anemia status to be severe, moderate, chronic, and non-anemic. I have 4 groups of anemia patients. I can also use binary logistic regression. How? What I will just have to do is to group these people into 2 categories. No matter how much the categories is, I have to what? Group them first into 2 categories. It's either you are anemic or you are not anemic. Chikena, those are the 2 categories. Here, it's possible for you to be rich. It's possible for you to be averagely poor, but I don't want to care how many categories of rich people we have. I've just grouped them into is either you are rich or you are not rich. And that is going to be our dependent variable tonight. They are all measured on nominal scale of measurement. On nominal scale. On nominal scale. Now, there are some assumptions that we should also consider before we do this analysis. One of them is the dependent variable must be measured on a continuum on a dichotomous scale, like I've said before. Now, this analysis or binary logistic regression, it doesn't really care about the distribution of your independent variable. It doesn't really care if they are normally distributed or not. It doesn't really matter. So we're not going to waste our time to check for assumptions. Just you can browse and read up about the assumptions. So let's go into analyze tab, regression, and binary logistic. Now I choose binary logistic. I'm resetting these guys. When you choose it, this is the table. This is what you have, right? So the dependent variable is the variable we are trying to predict. It goes into the dependent box. And okay, I want to include region in my model. I want to include place of residence as well. I want to include your educational level, and I want your ethnicity. Don't let us include much so that we're able to interpret our output very easily. Let us use these 4 guys as our independent variable. Now, when you throw these guys inside this box, this categorical button becomes active. When this guy was outside, categorical button is not active. But when you throw them inside this place, it is active. Now, when you click it, what it asks us to do is that which of the variables are categorical. In this case, all the variables we are using to predict health index are categorical. So we throw all of them inside the covariate box. Now, admitting we have maybe age or weight that is measured on a continuous scale as part of our covariate. We are not going to include it inside the categorical box. We only do it. Now, what I'll do now is to SPSS my reference category. By default, what we have as our reference category is the last category in the variables. And that is why it is here. Last. For me tonight, right? Me categories. I want us to use the first category. I choose first. After choosing first, I'll click on change. And everything should be the first categories of for every variables here. Now, let's continue. The next thing is our save. If we want to predict probabilities, we can choose, you can click this box, but let's just continue. Let's leave it the way it is. Come to save. Okay, sorry. Come to options. There are many options here. You can, when you are trying it on at your hand, you can try to explore. But for tonight, let's check the OSMA. Let's show goodness of fit test, and let's choose the confidence interval for our exponential of the parameters. So I check the two of them and I'm good to go. The style, we don't need it. The bootstrap, we don't need it as well. Now, this method here is the default setting for original binary logistic regression. You don't tamper with it. So leave it as enter and OK. Here we have my output, and the first table here is just our case processing. We don't need it, just telling us if we have missing values in our data set. And we can see here that there was no missing observation. So let's move on. Now, the dependent variable encoding, it shows us how it's coded our dependent variable. The non-reach is 0 and the reach is 1. Okay. Now, let's go to the categorical variables coding. Now here, remember, I said I choose the first categories of each variable as my reference category. Okay. In region, we have, let me activate this. In region, we have 6 categories: North Central, Northeast, Northwest, Southeast, South-South, and Southwest. 6 different categories. Now, when we are creating dummy for these categories, we don't create 6 dummies. We create 6 minus 1 dummy variables. That will be 5 dummy variables. Now, the one we did not create dummy variable for is going to act as our reference category that we are going to be comparing others to. We understand better when we start interpreting our odds ratio. Now, remember, I said the first one should be my reference category when I was doing the analysis. Now, that is why it didn't create dummy variable for the first one. The first one here is central. We can see central is a 0, 0, 0, 0 or true. There was no dummy variable for central. But for northeast, it created dummy. We can see one here. We can see here as well. We can see here as well. We can see here as well. Okay. Now, here, North Central is our reference category. It is very, very, very important for us to know our reference category. Okay. For ethnicity, my reference category as well is Hausa, the first category of the variable ethnicity. For highest educational level, the reference category as well is no education, the first category for highest educational level. And for the place of residence, It didn't create dummy for urban. It only created dummy for rural. So my reference category is the urban area. Now let's move on. Excuse me some seconds, please. Okay, now for the block 0, can we still see my screen? Are we following me?
Yes, I can see your
I
screen,
need a
sir.
response.
Yes, I can
All
see
right,
your
thank
screen.
you. All right. Now for block 0, the block 0 part, you are going to see classification table, the variables in the equation, and the variable not in the equation. You will see 3 tables. Now, what this part does, we don't actually need it in our analysis or in our interpretation. But what it does is that it gives us the output for our binary logistic regression, given that there was no independent variable that is included in the model. In the block 0, it runs the analysis without putting any independent variable. You know, we have 4 independent variables. It will not put any of them in the equation. Okay, now when it didn't put any of them in the equation, we have a 52.5% correct prediction. Okay, and these are just, this is the only variable that's in the equation, which is the constant. So now what this also does is that it provides a baseline. It's something for us that we can use to compare our model to when we include all the variables in the model. Now let's move on to block 1, the main output. Okay, now let's move this omnibus test of model coefficients. It's it is significant if p-value is less than alpha. If p-value is less than alpha. Now, what this omnibus test does is that it tests for the model adequacy. It compares the model that we fitted, that has all the variables in the equation in the model. It compares it to when there was no variable in the equation. So if the model we fitted is a better model for the data set, okay, this omnibus test is going to be significant. I don't know if you understand. This omnibus test will be significant if if our model is a good model for our data. If the model is better than the model we have up here. So if you are going to be interpreting anything in your analysis, you start with the omnibus test of model coefficient. You state the hypothesis, H naught, the model is adequate. The model is not adequate. H naught, the model is not adequate. H1, the model is adequate. So you reject H naught if p-value is less than alpha. So in this case, our p-value is less than alpha. I mean, the p-value for the model, the p-value for the model is less than alpha. So we hence conclude that our model is significant. Now the next thing that you interpret in your output is the model summary. Now the model summary gives us two R square, two types of R square. The Cox and Snell and the Nageke. I don't know how to pronounce that, I'm sorry. It provides these two types of R square. Now, this second type of R square, I mean this guy is the adjusted Cox and Snell R square. So it is a better R square than the Cox and Snell. Now, what these R squares are, they are just a pseudo R square. They are like the R square in our ordinary least square regression. they are equivalent, they can be used like the R square in our OLS regression. So in what it does, we have to, when using this R square, we can use it the same way we are using the R square in our multiple linear regression. But we have to be very careful with the way we use it. Now, what it is saying is that 48.3% change in the criterion variable can be accounted to the predictor variables. Like what this is, you convert to percentage. Then you say 48, or you can say the amount of variability that can be explained by the predictor variable in the model is 48.3%. Now, we move to the Oshma and Lemshow test. Now, the Oshma and Lemshow test sorry. This test itself, it tests for goodness of fit. It's a test of goodness of fit, and it tests for the fitness of our model. Now, the null hypothesis for this test is that the model is a good fit to the data, and the alternative hypothesis is that the model is not a good fit to the data. So reject H naught if p-value is less than alpha. Reject H naught if p-value is less than alpha. So you can make your conclusion based on the hypothesis. Now, we've not gotten to the main output that we are trying to drive at. This is the continuous table for the Oshma and Lemshow test. And then the classification table. This is
what are the problems you are trying to solve? Apart from that, what are the
now this classification table can be compared to what we have in our block 0. Remember, I said the block 0 output is the output that we have when there was no independent variable included in the model. Now here,
first I need to understand
when there was no independent variable in the model,
the data is much to semesters. I want to understand what exactly are you trying to solve, like what problem is occurring for you, so I can understand where I can now start putting you through.
sorry, I'm here someone saying something for me.
Hello. Mr. Osho, please, can you
Yes,
switch up or mute yourself, please? Mr. Osho, can you mute yourself?
okay. Now, remember when we had our block 0 up here, I said the block 0 tries to fit the model without including any independent variable, without including any predictor in the model. It will not include place of residence, it will not include educational level, it won't include ethnicity or region. That is for block 0. Now, the classification for block 0, we have 52.5% correct prediction. We have an overall 52.5 prediction. But now, when we have our variables included in the model, we have a total of 78.8 correct prediction. We have a total of 78.8 correct prediction. That shows that the model is quite better when we have our variables included in the model. Now, this very guy here is at the correct prediction. This guy and this guy, I'm trying to highlight the two of them so that we see. These off diagonal digit numbers, they are the correct predictions. Now, our model predicted our model predicted this number correctly of respondents, when in actual sense they are not. And it predicted this amount of respondents to be rich. I mean, these people to be rich, when in actual sense they are rich. Now, these guys, they are our correct predictions. Now, the other way around, this man and this man. Now, our model predicted these people to be not to be rich, when in actual sense they are rich. And it predicted these people not to be rich, when in actual sense they are not rich. Now, the percentage correct, the correct percentage, it predicted, it have an overall of 78.8 correct prediction, and it is not bad, since this is not a medical data. When it's a medical data, we expect something here, a very, 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 very good level of prediction before we can say the model is good. Okay, now for the main output. Now, whenever we run a binary logistic regression, the most important thing is for us to use the odds ratio. And the most important thing we use for our interpretation is the odds ratio. Now, these columns, this column having B, they are the parameters, beta 1, beta naught, beta 1, beta 2, beta 3, and so on and so forth. These are our betas. And these are the standard error of the beta. These are the degrees of freedom, and these are the significant level, the p-values. Now, for us to know if a category is contributing meaningfully to the model or not, we are going to check for this column, the p-values. Now, for region 1, our region 1 is, let me check for region 1. Region 1. Region 1 is northeast, northwest. Let's just go back to now. The region 1, northeast, northwest, like that. Now, the region 1, the hypothesis here is that the variable is not significant. Okay, beta high equal to 0. That's the H naught. The variable is not significant. And the alternative hypothesis is that the variable is significant. So we are going to reject H naught of non-significance if our p-value is less than alpha. So for this particular variable, this particular category for the variable region is significant. This one is also significant. So like that. Now this one is not significant. This one is not significant, and other ones are significant to the model. This is our constant. I mean the beta naught. While other ones, beta 1, beta 2, are there. Now, if you remember, we have 6 categories in our region, but on our table here, we are going to be getting output for just 5 categories, which is these guys here. We are going to be having output for just 5 categories. The reason being that it has used the first category as our reference category. And we're going to see how we are going to interpret with our reference category now, which is where we are going majorly. Now, for place of residence as well, if you remember, we have two places of residence. We have the urban and rural. The urban was the first and the rural was the second. It used the urban as our reference category, so it is not included. So we are going to be having just one place of residence, and that's what we have here. Educational level as well. We have 4 educational level, but now it provided us with just 3 educational level, right? The last one is used as our reference. The first one is our reference category. The same thing for ethnicity. Now let's see how we interpret our data, our output. Let me open my Word so that we can type. We can have the report. Okay, I'm going to my screen.
Yes, sir. We can see your screen, sir.
All right, thank you very much. For region, now if you look at the region, whenever we have beta, the value of our beta to be negative, the odd ratio, I'm sorry, this is the odd ratio. The exponential of our beta is our odd ratio. And if you take the exponential of this value, this is what we are going to get. And this is our odd ratio. Whenever we have our beta to be negative, the odd ratio is going to be less than 1. To be positive, the odd ratio will be greater than 1. This. Okay. Now, for region.
Hello, Tutop. Question, sir. Sorry, I have question.
The first region here is okay.
What do you say?
I didn't hear you.
Okay, I said I have question.
I didn't hear you.
I said I have question.
Okay.
I have question.
Go ahead with your question, sir.
Okay, my question is how do we interpret odd ratio from the binary logistic output?
That's what we want to do now. That's what we want to do now. That is what we want to do now. That's why I opened my Word so I can type and you can see. Are we good? Yes, we are good. Now, for the first row, for region, the first region here is northeast. Okay, let me be sure of how the region is arranged. North central is our reference category, so you have to note reference category southeast, southwest. So let me go back to my output. Northeast, northwest, region 3 is southeast, region 4 is south-south, region 5 is southwest. Okay. Now, the report now. For region, the odd of having a rich person coming from the northeast region is now, whenever our odd ratio is less than 1, we are going to be having less likely. And whenever our odd ratio is greater than 1, we are going to be having more likely. Now, but for less than 1, we will not just write this odd ratio. I will need my calculator. Okay, now whenever the odd ratio is less than 1, so we're going to say 1 over 3.7, 1 divided by 0.371, which is 2.695. So we say the odd having a rich person, remember, rich and non-rich. Rich person coming from not is 2.695 times less likely than having a rich person coming from the north central region. That is our ratio. Now, the whole of having a rich person is 2.695 times less likely because the odd ratio is less than 1. Okay, less 2.695 times less likely than having a rich person coming from the north central region. Now, why did we compare the person from northeast? Remember, north central is not on this table. It is because it is our reference category. So every we're making, we'll be comparing it back to north central. Okay, now let's look at the next one. I won't be able to interpret everything, but basically, this is how you just go about it and write your reports for region. Now, okay, you continue. Now, for northwest, what is the odd ratio? The odd ratio is this. Now, the odd, or you say the probability, okay, the odd of having a rich person coming from the northeast region is this odd ratio. 1 divided, you divide it by 1, like 1 over 0.423, 2.364, 2.364 times less likely than having a rich person coming from the north central region. So that's how you go about interpreting it. Now, when we get to, let me jump to this one that is greater. Which is for, I think, South. The respondents from the south region is 1.797 times more likely than having a respondent. Okay, so whenever the odds ratio is greater than 1, we'll be having times more likely. But whenever it is less than 1, we divide that odds ratio. We use 1 to divide the odds ratio, and it will be less likely. Okay, so now, let me assume that's how you just go about it for region till you finish region. Now let me jump to one of the variables, another variable. Let me now, in actual sense, let's reason on this together. The first statement here said the chances of having a rich person coming from northeast, that is, it is less likely, which implies that north central people can be richer. That is just what this is trying to say. Also, for this guy, the chance of having a rich respondent from the south, that is this guy times more likely. What is saying is that people from the south, like people from Calabar, they are rich than people from Kwara or from Kogi, you know. And in actual sense, it is reasonable because, okay, so let's look at ethnicity. So let's look at ethnicity. So ethnicity. Okay, now for ethnicity one, let's get it right. Let's go back to our data. Which one is the ethnicity one? Ethnicity one. Ethnicity. Now the first category here is the reference category. Hausa is the reference category. You note it. Then Igbo, Yoruba, and other tribes. So ethnicity. For the first ethnicity, the Hausa has been used as reference category. So the Igbos now. Now the chances of having a rich respondent from the 1.217 is 1.21 is 1.2117 times more likely than having a rich respondent from the Hausa tribe. What this is saying basically is that the Igbo tribe, according to the model we fitted, is that the Igbo tribe is richer because they are more likely to be rich than the Hausa tribe. Okay. Also, the next one are the Yoruba group. The thought of having a rich respondent from the Yoruba tribe is, this is the odd ratio, is 1.5 is 1.544 times more likely than having a rich respondent from the Hausa tribe. Okay, finally, the chances of having a rich respondent from other tribes, I'm talking about tribes like Efik, Ibibio, Fulani, it is like that. Is now this particular one is less than 1. So 1 divided by 0.8, 1.25. So you say is 1.25 times less likely than having a rich respondent from the Hausa tribe. What this is saying basically is that the Hausa tribe are richer. That is, you can have there are higher chances of having an Hausa that is rich than having people from other tribes that is rich. So that is how you just go about it, one after the other, to interpret your output. However, in some cases, you don't interpret for the ones that is not significant. For example, the Southwest here is not significant because the p-value is greater than 0.05. So it might not be necessary not to interpret for the Southwest. But however, it can also be done. So that is just how we use our odd ratio for interpretation in binary logistic regression. Any questions so far on the interpretation parts? Let's entertain question.
Okay, I have question.
Okay, go ahead.
Okay, for the interpretation on the for the binary logistic, is it only the odd ratio we are going to interpret, or we can use any other result in the output to interpret?
Okay.
Thank you, sir.
You're welcome, sir. So it is the odd ratio that we use to write our reports. Right? Now, other things here, if you want to write your model, you can use these betas to write your model. These are the standard errors of your beta. This is the wild chi-square. Basically, I don't know what it is used for, but it's also a test. But if these are the degrees of freedom. We all know what degrees of freedom is.
Okay.
Now the
Yes,
the
sir.
p-values is showing if these variables are important in the model, if they are contributing significantly to the model. So we will definitely
Okay.
talk about, so you definitely write about all these p-values as well. It's a thing that you will, before the report, before writing this report, you will write the hypothesis, okay, for H naught. For H naught, for H naught, you'll be like beta high equal to 0 versus H1 H1 beta high, excuse me, not H naught. Okay, so this is going to be like I equals to I equals to 1 to how many betas do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I equals to 1 to 13. So, and the other hypothesis is that beta i's are not equal to 0. So what this implies is that the parameters of the model is not different from 0. And this one, the parameters is different from 0. Now, you reject H naught if p-value is less than alpha. So for for all of these guys, we can see that the p-values are less than alpha. So you just be like, you just come to your report and say, oh, okay, all the variables have p values less than level of significance, which is 0.05, except which variable. Let me check. Except southwest region. Hence, the variables are significant in the model. So you just write the appropriate conclusions to show that you tested for the parameters of your model. Also, before you do these ones too, remember, we talked about the omnibus test. The omnibus test is up here. The omnibus test is what will come first. The table will be there. You put the table up, and you write the hypothesis for omnibus test. The hypothesis for omnibus test, H naught, the model is significant, is adequate. H1, the model is, sorry, H naught is the model is not adequate, while H1 is the model is adequate. So you reject H0 if p-value is less than alpha. So here, since p-value which is less than 0.001 is less than level of significance, we reject the null hypothesis. Hence, we conclude that the model is significant. Okay, so that's also how you come up with. Also, for this man as well, this model summary, you write about the R square, or this pseudo R square. It's just a very short meaning of the model summary. Also, for this Oshma and Lemshow test, you read about it. It has an hypothesis. The hypothesis is that the model is a good fit versus the model is not a good fit. You conclude appropriately before you go to classification table. Now, this classification table, you can actually say a lot of things about specificity and sensitivity. Okay, so you can say a lot of things about true positive, true negative, about the what's it called? So you can just say a lot of things about them. The reason why I just jumped to the report of this one is because it's actually the most important and is where most people used to find difficult. I hope. Any other questions, sir?
Thank you so much, Sabidex. I have another question, sir.
Okay.
Okay, before I proceed, please, do anybody have question before I proceed? Okay, let me proceed to my question. The next question I want to ask is from our data set. So
Okay.
how are we going to know that, okay, I want to do binary logistic for the project or for my analysis? Because
Okay. Thank you very much.
thank you.
Thank you very much. Yes. Before we start the analysis, I actually mentioned the scenario where that will warrant us to conduct a binary logistic regression. Now, there are types of logistic regression. We have multinomial, we have probit. Okay, so now the binary logistic regression warrants us that we should have a response variable that is measured on a binary response. So when we have is that the dependent variable that we're trying to predict is measured on a categorical variable that can be grouped into two, then we should consider using a binary logistic. If the response variable can be grouped into two categories, and we think that we have some set of predictors that we can use, we have some set of predictors at hand that we can use. Okay, for example, it is this analysis is mostly used in medical fields, where we want to know the status of a person's health. Maybe the person has a particular ailment or not. It is a binary response. Purely binary response. Either you have HIV or you don't have HIV. It's either you have anemia or you don't have anemia. So it is a binary response. There cannot be another response. Okay. Now, in medical field, whenever we this can be used for prediction. I didn't click the output for the prediction. So whenever we think that, okay, I have a set of independent variable that, okay, I know the blood group of this person, I know his age, I know the gender, and I know, okay, that's okay. That 3 variables, I want a model such that if I put it inside that model, it will be able to tell me that the person is HIV positive or HIV negative. Then consider using binary logistic regression, because your dependent variable is measured on a binary scale. It's either 0 or 1. It's either you are sick or you are not sick. Do we understand?
Oh, yes, I understand. Another question from here, sir.
Okay.
Okay, what if
Right, sir.
I want to do binary logistic, but my data set is not in binary scale. So how will I do that?
Okay.
How will I go about that, sir? Thank you.
Okay. Thank you very much for that question. If you insist that you want to use binary logistic regression, one very important thing that you must have in your dependent variable is that it was measured on a categorical scale. Once this measured on a categorical scale, I don't want to know if it is measured on a 5 scale or a 10 scale. You should have a criteria that will enable you to group it into 2 categories. I use educational level as my dependent variable. But we can see that this educational level is not measured on a 1 and 0. It's not measured in 2. It's not measured on a binary response. This is 4 responses. Okay? I can actually group it into 2. How? Okay, since I feel like I want to use binary logistic regression, I can decide to say, okay, people that attended people that had no education and primary education, I should give them non-educated. And people that attended secondary education, that have secondary education and higher education, I should group them as educated. I've grouped it into 2. Binary response already generated. Okay, if it is my age, do I have age here? Do I have age here? Age. Oh, I don't have age here. Okay. So, for example, this total number of children it can be, you can have like 4, 5, 6 children. Okay. Now, by the time I can now decide to group it into moderate number of children and excess number of children, in the sense that anyone that have just 1 to 2 children, I will group them under moderate number of children. If you have more than 2 children, 3, 4, 5, 7, 10, I will group you under excess number of children. I already have my variable grouped under binary response. So if you feel like you want to do binary logistic regression and the variable you want to measure, you want to predict, is not measured on a binary response, the best way is to look for a way to group them in 2. You can always group everything in this life into 2. Okay? If you are anemic, if you have anemia, it's either your anemia situation is either it is severe, either it is moderate, or it is chronic. Okay, or you don't have anemia at all. Those people that their anemia level is severe, chronic, and moderate, you can group them to be anemic. And those people that they don't have anemia, leave them separate. You have already grouped your dependent variables to be 1 and 0. Binary response. It's as soft as that. Do I answer your question, sir?
Oh, thank you so much. You answer my question, sir. Thank you so much, sir. And